Today we're looking at what makes a function. Right now what we are looking at is what's called a function map. And in this map we have some x's and we have some y values. Now these x values are all referred to as the domain, and these are the inputs. This is what you would put into a function, and the y values are what we are going to get out. So, and the output values are referred to as the range. So right now we could list out the domain of this particular function as going from smallest to largest. We have a -6, and sometimes we put it in these little squiggly brackets here. We have a -6, a -3, a 0, and a 3, and then we'll go ahead and close it off. And really all we're saying is these values here are all the values of my domain. So let's go ahead and do the same thing. We'll go ahead and list out the range, and the range are all the y values. And if we go smallest to largest, this time the smallest one is on top. We have a -1, and then a 0, and then a 2. And those are all the output values for this particular function. Now what makes it a function is that every one of these domain values only shows up one time, meaning there's no repeats. So this 3 only goes to a -1, the 0 only goes to a 0. Notice this -3 also goes to a value of 0. So this 0 in the range gets repeated, but that's okay. That doesn't nullify it from being a function, because what would matter is if any of those domain values showed up more than one time, then we would not have a function. But as long as these only show up once, we're okay. So let's take a look at some other things that we can determine based on what we're looking at. And here is something called a vertical line test. These functions all can be graphed. We can represent them with a graph. And the vertical line test is really pretty simple. All it says is, if I draw a vertical line across my graph, as long as I only touch it one time, which in this case would be like right there, then it's still a function. But if you look here, this vertical line actually crosses right there and also right there. And because it crosses twice, that means it's not a function. This point would actually come, this ordered pair would say go over x and up some value, let's call it a. That might be an ordered pair of x, comma, a. And this ordered pair down here would also be over x. And maybe it's down some other level, I don't know, down b. It's a negative number, it's below the x-axis. But look, the x actually goes to two different outputs. It goes to an a up here and a b down here. That's why it's not a function. And then take a look here. Here's a vertical line. It crosses this ellipse, and it crosses right there and also right there. So that makes it not a function, actually fails a vertical line test. Here's a bunch of graphs here. If I were to draw a vertical line, I can draw vertical lines across here, and I'm only going to touch it one time. If I come to this horizontal line here, I can only touch it once at a time, so it's a function. But look at, here's a vertical line. If I draw a vertical line right down the middle, I hit it an infinite number of times, so it's not a function. Right here, yep, you're okay, because a vertical line can only touch the graph once, but here we fail, because a vertical line would touch right there and also right there. That'd be not a function. A vertical line also touches right there and right there, so that's not a function. This one's okay. I can draw any number of vertical lines down there, and they only touch the graph once. But here, look, if we draw this vertical line right here, it touches twice. Okay, when it touches right there and right there, it means it's going to fail a vertical line test. That's why that's not a function. And here's another circle. Circles and ellipses really aren't going to be any different. If you can draw a vertical line and touch the graph more than once at the same time, then you are not a function.